In this video, the teacher asks her students to explore in groups whether a set of mathematical statements are always, sometimes, or never true. The students are then asked to work on the rigor of argumentation in order to learn that mathematicians have to prove the strength of their arguments before they're accepted.
So we're going to start with an interesting activity here, where we are going to actually talk or think like mathematicians. And the primary thing that the mathematicians all the time do, they question, they debate, they have differences of opinion, they discuss, they try to reason out whatever they are saying, and then come to a conclusion. So we are going to behave like mathematicians today. We will talk about certain statements, certain facts. I have put across a few statements to you, and I want you to discuss it amongst yourselves in groups, ask each other questions, and see how many of you think that these statements are always true, sometimes true, or never true. The first one is, if p is a prime number, then p plus 1 is a composite number, right? The second one is n chords of a circle, divide it into n plus 1 non-overlapping regions, right? Third is if the volume of two spheres are equal, right? Volumes, not capacities, right? Then the spheres are congruent, okay? The centroid of a triangle lies inside the triangle. We've just discussed about the centroid when we discussed about the test recently. And then there are infinitely many prime numbers, right? So these statements are open for discussions amongst your groups now. I want you all to rearrange yourselves into the groups, but please make sure that everyone participates in the discussion, because everyone has some point of view. You can begin with any one of the statements. You could start with the third, then move on to the fourth, then first. You want to start with the geometry statement first, I'm fine with that. You want to talk of mensuration, that is volumes 1. It's all right. Yes, now you can turn around, please. All of you. Sarthak?
It won't overlap. You try any chord, it won't overlap.
Yeah, right, because it's not on the same size.
No. See, this is, we take a practical. We draw chords. We keep on drawing chords and chords. Do the regions formed by them overlap?
But it can't overlap, right?
But it's not all.
Yeah, that's what I'm saying.
But it's not intersecting now.
रैशनल नंबर्स डिस्कस कर रहे हैं ना, तो रूट रैशनल का किसने का रैशनल डिस्कस कर रहे हैं, बट प्राइम इज अ प्राइम नंबर देन p + 1 इज कंपोजिट, इसमें रियल नंबर्स बट रियल हो ना.
अगर क्यूबॉइड का लेंथ सेम है लेकिन उसका जो डेप्थ है वो ज़्यादा है, तो फिर उसके डायमेंशंस चेंज रहेंगे और शेप भी चेंज रहेगी.
बट कॉन्ग्रुएंट फिगर में हर एस्पेक्ट सेम होती है,
तो इस वजह से
स्फीयर में देयर इज नो एस्पेक्ट, देयर इज नो एंगल, देयर इज नो लेंथ.
बस एजेस ही तो होते हैं.
एजेस कहाँ पे?
एजेस भी नहीं होते, वर्टिसेस नहीं है. The basic thing I liked about this session was that everyone was able to express their ideas and opinions about a particular topic. They were able to express them freely.
All right, class. So let's just begin with the first statement.
The statement is, if p is a prime number, then p plus 1 is a composite number. It is always true, but there is an exception. If p equals to 2, then p plus 1 equal to 3, and that is also a prime number. And 2 is also a prime number, so this is an exception to this case.
There cannot be only one exception, because we don't know where the numbers end. So if the numbers are infinite, then prime numbers are infinite, so exceptions can be more.
There can be more exceptions to it. Anyone who has something else to say on this?
There can't be any other exceptions other than the one that he said, because all the prime numbers other than 2 are odd numbers. So considering that all of them are odd, any odd number plus 1 gives us an even number. So each and every even number is divisible by 2, hence they are composite.
Does the entire class agree with this statement? That it is always true with only one exception, that is when the number is 2. Let's just move on to the next statement. N chords of a circle divide it into n plus 1 overlapping regions.
The statement is only true when the chords are non-intersecting. And like if we draw two chords and if they intersect, then the circle would be divided into 4 non-overlapping regions. But if these chords are non-intersecting, then the regions would be 3.
Ma'am, would satisfy that n plus 1 is equal to 3, that is 2 plus 1 is equal to 3.
You all agree with it? That this is true when the chords are non-intersecting. Can we think of any value of n where it is unconditionally true? 1. When n is 1. All right. Okay, let's just move on to the next statement. If the volumes of two spheres are equal, then the spheres are congruent.
Ma'am, according to me, the statement will always be true because the volume of a sphere is 4 by 3 pi r cube, where 4 by 3 and pi are always constant. Since both the spheres have equal volumes, that means r, that is the radius of the spheres, is equal. That makes them congruent.
Any disagreements here? All right.
Ma'am, I disagree with her. Ma'am, since we are talking about volume and not capacity.
The discussion that we had earlier was really interesting. We really came up with a lot of arguments. And whatever we were saying, we tried to back it up with the proofs. And that's how actually a mathematician has to think. Right? So in other words, can I say that we have already started behaving almost like mathematicians. Now let's just move on to another level. So now we will have a discussion in pairs. You look at the last two statements. Think of it. First, give yourself 2 minutes. Convince yourself. Right? Then convince your partner. Right? So we can try convincing and we will come up with reasons. The reasons could be in terms of illustrations, using figures, using examples, using numbers, could be anything. Right? So that's what we can do. And once we have convinced ourselves and our partners, we'll probably move on to another level, convince any mathematician. Let's say convince Ramanujan. So that means when you reach that level, your proofs, that whatever you are suggesting for whatever statement, those proofs have to be lot more in your mathematical vocabulary. All right? So can we begin? Last two statements. I give you a minute or two to first convince yourself. All right. Now I hope that you have already convinced yourself. I want you to start working in pairs and start convincing your partners. Please do make sure that you cross-examine each other, right?
There's no limitation for numbers. So I think like prime numbers would also be infinite and they would never end.
Yeah, I agree with that. But according to me, I think that it's not, maybe not true. But as I'm going down and as 1 to 10,
but then 10 to 20. Like we take a number like 579.
Don't you think that centroid can lie outside the triangle? Why?
Because all the medial lie inside the triangle.
I can draw meaning from here also.
Just show it.
If we this triangle, then
I see that there have been some heated discussions, arguments also. So who do you think has convinced his or her partner the best? The statement is the centroid of a triangle lies inside the triangle.
Ma'am, a median of a triangle is that line segment that joins a vertex of a triangle to the midpoint of the opposite side.
Okay.
So the median has to lie inside the triangle.
Okay. That's your argument.
Yes, ma'am.
Does anyone have any other question to ask beyond this? Yes.
What is in the case if one angle is 0 degree and the other is 90 degree?
It's not an angle.
The basic property of a triangle is that all the three angles have to add up to 180 degree. If any one angle is 0 degree, it won't add up to 180 degree.
Ma'am, if any one angle of the triangle will be 0, then ma'am, two lines will overlap each other, and ma'am, obviously it won't be a triangle.
I do not talk very much, and I rarely ask teachers for any doubts. Even if I have one, I keep it to myself and try to solve it myself. This activity has personally helped me get out of my bubble and stand up and speak. I learned that it is not necessary that I have to be right always, and I could be wrong. My thinking methodologies could be wrong.
The statements are already proved by mathematicians, and then our teacher tells us how to prove it. But today we learned how to prove it ourselves, how to prove it by ourselves, and it helped. It even helped us because I guess we all came to know about our capability.
Did you find that your arguments were varying from the level when you were convincing yourself to the level when you are convincing your partner or friend, or when you moved on to a higher level of criticality? Maybe Aditya can say that because he was questioned by the mathematicians so much. So let's just see what was his experience about the difference.
Ma'am, all the three experiences were, were increasingly difficult because, ma'am, convincing yourself is easy because it is your mind that is doing the thinking, and it will never look at the negative aspects of it. Convincing your partner is somewhat difficult because there is another thought process that runs in your mind, and you have to counter it. And convincing Ramanujan is even more difficult since he can produce even more counter arguments to your argument, and you will have to rethink all of what you have thought already.
Two assignments that I want to give you today are: one, think a little more about these two statements. One, the centroid of a triangle always lies inside the triangle. The second one is there are infinitely many prime numbers. Think of more arguments in favor or against whatever you think is true. Also, think of some more proofs, some more statements on your own, which you think you have very clearly understood. And then we will take them up in the class sometime, and we will see what we have to say about it, or what your partner has to say about it, or what anybody as Ramanujan has to say about it. Teaching is always learning something new. I discovered that this could help my shy students or the ones who are introvert come up a little better than in the regular classroom setting, because when they are amongst their peers, it is so much more easier for them to converse with each other without having any fear of the teacher being judgmental or saying, no, this is wrong.
Asking students to explore whether mathematical statements are true helps them to think deeply about mathematical properties. Allowing students to voice and argue their mathematical thoughts helps them to improve and enjoy their mathematical communication and reasoning skills.